So far, all our treatment relied on global modeling and transforms, and now we would like to revisit the separation and the in-painting tasks using patch-based modeling. If we believe the trend we saw in denoising, such migration to patches should be worth of our efforts. Let's define the MCA on patches. Here is the image X, believed to be the sum of a cartoon and a texture images. This relation remains true for the patches of these three images. Mathematically, we will say that the kth patch from X, Rk times X, should be close to dt times alpha k plus dc times beta k. In this expression, the two dictionaries are local, creating patches. Another way to write the expression is this, in which xc and xt replace the image X. The epsilon deviation is not an additive noise, as all the images we mention here are clean. Rather, this is the mismatch of the model, the error we allow in the separation. By using the following definitions, our separation problem can be written like this. We are given a noisy image Z, and we are searching a clean version of it, X, that will be the sum of cartoon and texture contents. We require that every patch in X has a texture and cartoon contents that can be described sparsely by a local dictionary D. Observe that D itself is also defined as an unknown, being the concatenation of the two dictionaries DC and DT. Have you noticed what we have just written? This is the patch-based denoising algorithm that we thoroughly discussed earlier. So where has the separation gone? The answer is simple. The process we propose is blind to the separation somehow, but once solved, we could create the separation desired. So let's concentrate now on solving this problem, as we have already seen how to do it. We start by pursuit to each of the patches in Z, proceed by a dictionary update, run these two steps back and forth, and conclude with a calculation of X by patch averaging. And now let's extract a separation from the denoising solution. We finished the denoising process, which created the dictionary D as shown here, and we know that it is a combination of DC and DT. Our goal now is to separate it into two parts. We will do so by assessing the activity in each atom by total variation. If the atom is textury, we'll assign it to DT, and if it is smooth or piecewise smooth, it will belong in DC. And this way we get the two sub-dictionaries. Given DC and DT, we can suggest a separation. The dictionary separation induces a similar separation on the sparse representations of the patches. All that needs to be done is to perform two separate patch averaging processes, as these equations show, and this will get us the global cartoon and texture images. This is in fact a suboptimal approach, so we now turn to describe a better treatment. Here is our denoising energy, and the representation error of each patch can be written like this. We simply replaced X by Xt plus Xc and gamma k by its two parts, alpha and beta k. Now we do something that you might find as strange, rewriting this L2 expression as the sum of two parts, one holding the texture representation error and the other holding the cartoon one. This is indeed equal to the original L2 error only if the cartoon and the texture errors are uncorrelated, a property we actually would like to impose. With this modification, we come back to the denoising expression and rephrase it as shown here. The beauty in the new expression is that the unknowns are the global xt and xc. Once all the sparse representations of the patches were found, we can optimize with respect to the two images, and here is the expression we get. Interestingly, for lambda equals 0, we return to the separation suggested earlier. From denoising, we know that lambda equals 0 is not the best value, so we expect this to perform slightly better. Let's see some results. These are the cartoon and texture parts we obtain for Barbara. Is it of better quality compared to the global approach? I think the answer is positive. The local option does remove cartoon content very well from the texture and leaves almost no traces of the texture in the cartoon.